We have a distinguished panel joining me up here.
Distinguished.
In no particular order, John Thales, Steve Brumer, Doug Gardner, and brain blank, Andrey, Nikishin. I'm going to introduce each of them, and then we'll get started. Let me start with Andrey. Andrey is Special Projects Director of Future Technologies at Kaspersky Labs. He's got a career that stretches back to the early days of Kaspersky Labs. He worked as a senior software engineer and architect before moving to the strategic marketing department as a product strategy manager. Prior to this, he headed cloud and content technologies research and development. And before Kaspersky, he had several years developing his own antivirus programs. So the man is a deep techie from way back.
Thank you.
If I may, John on the end there, John Grimm, is Senior Director of Security Strategy at Thales, e-security. He's responsible for IoT security strategy at Thales, an industry leader in advanced data security solutions, delivering trust where information is created, shared, or stored. He has 25 years experience in lots of areas, including PKI, identity management, encryption, networking, and the cloud. A BSc in electrical engineering, and a member of the Tau Beta Pi, the Engineering Honor Society. So that's John. Doug Gardner, there we go, is leading research and development efforts. He's first the CTO at Trusted Security Solutions Analog Devices. He's currently leading research and development, providing secure solutions for smart cities, Internet of Things, industrial control systems, high assurance control systems, endpoint security, and silicon. A veteran systems architect, long history of creating innovative solutions, led many successful transmission and computing systems spanning all sorts of communications, wired, optical, wireless. Extensive background with secure communications, secure computing platforms, identity, and key management. And finally, we have Steve Brumer, closest here. You were the first up, you're the last down.
Why not?
Steve leads the IoT practice at 151 Advisors, a global advisory and execution firm, advises companies on establishing new market positions and accelerating the growth of their products, services, and revenue. With over 30 years industry experience, Steve's specialty is monetizing the connected world. He creates real-world execution plans, driving revenue growth to enable companies to realize their full commercial potential. Before 151 Advisors, Steve co-founded and served as the CEO of Wireless Rain, which helped wireless carriers, manufacturers, solution providers build channel programs for B2B products, M2M products, and professional services. So we have a distinguished panel here. The topic today is innovative technological approaches to cybersecurity for, obviously, the IoT and the industrial IoT. So we're going to be talking about technology. So let me start with a question, and then we're going to open it up to the floor. My first question to the panelists, our topic is innovation in cybersecurity technology for the Internet of Things. What does each of us believe is the most important technology that we should be watching that enables cybersecurity for the Internet of Things? And if I may start for just another 30 seconds, I'm probably going to disagree with most of these people. I'm with Waterfall. We deal with the most cautious end of the industrial security spectrum. Railway switching systems. Hack into them and people die really quickly. Power plants, critical infrastructures. Our customers tell us the most important technology they're looking at is physical protection for the plant. Instead of relying exclusively on software, they want a layer of physical protection. They want to be able to send information to the internet, but it should be physically impossible to send anything back. And there is technology on the market to do this called a unidirectional gateway. I'm going to open it up now. Steve, you were introduced last. Would you like to weigh in first? From your perspective, what's the most important cybersecurity technology that people should be watching in the industrial Internet of Things?
I'm not sure I would say there's one particular technology today. I mean, the group of people up here are delivering amazing technology around cybersecurity today. I'm not sure there's one specific answer for everyone, so I'm going to say I'm not sure it's invented yet. I think it's coming down the pipe where someone is going to come up with something that encompasses a lot of the things that everyone here is delivering today. I think that you're seeing customers today use everyone, sometimes all at the same time. We haven't even talked, I wanted to talk about eSIM. And then I'm going to deviate for a second. Consumer side is just as crazy as it is on the industrial side. We're seeing a lot of things from the Chinese market into our Hong Kong office where cybersecurity is extremely important, but it's being done in a variety of different ways. So my simple answer is that I'm not sure, everyone here has got innovative technology already, and it all works really, really well, and it's affordable, and it integrates really well with everything that's going on. So I think today everybody's got a great answer, but I still think that coming down the pipe, there's going to be something that maybe all of you guys will come up with that'll shock the world and allow all of us to really protect ourselves and protect our clients from cybersecurity threats and attacks.
Okay. Doug, would you like to take a shot at it? What is the most interesting or most important technology that people should be watching?
So as you look into the future of what I would call the hyper-connected world, you're going to have a blurring of a line between human, machine intelligence, motion of equipment. You're going to see, sensorizing the world and lots of decisions being made. So it kind of breaks down a lot of the boundaries. Information is going to be flowing whether you like it or not, and the human element is going to be removed from a lot of the decisions as we keep going forward. So to me, the most important part is just endpoint security. If you're going to start having endpoints that are now providing data and you're making decisions and real-time information based on that data, you have to be able to trust the data. You have to have methods of how you do updates and all those other little nasty things such that they remain secure, because they're at the end of the day going to be in control. And you need to have all the connections there to put you in place for the future. And then you have kind of the industrial market where there'll be lots of concern over people accessing or bringing down processes and everything else. I don't think that the traditional IT firewall method is going to work. It just doesn't scale. And you can't define where the boundary is anymore as things become wireless and vehicles start talking to vehicles. So what you really need to do now is start from the endpoint, and where you take the sensor data, you need to add in elements of identity and security at that point. And instead of trying to monitor it from up high and try to see if everyone's acting right, you need to start providing data, integrity, and trusted data at the endpoint and push that information up the stack where other decisions can be made, so that you're not making decisions on spoofed data and false data that you have no trust in.
Okay.
Yeah, Andrew, I'm from Kaspersky. You're definitely expecting that I said, okay, antivirus, that's the most important technology for IoT. But no. Actually, I believe that the most important technology for IoT security is the brain. Think before you apply the security. IoT, it's not endpoint only. It's a whole complex of endpoints, channels, clouds, gateways, even iPhones or laptops. And every single piece of that complex should be protected. Endpoint, definitely, that's extremely important. But we have clouds. And we have our iPhone, which is actually connected to our houses. And we can control remotely our house temperature or whatever. And if my phone is compromised, it means that my house is compromised as well. So think before you apply, think of a whole infrastructure, think about the threat model, risk associated, and how the hackers could hack your system, and then apply the technology. And you're absolutely right. We've got a lot of products on the market, so just suitable for different purposes, for different endpoints, for different routers. Just think and combine and find the right and proper solution for your needs. Brain, think.
There we go. And John, can you weigh in for us, please?
Sure, and I think this concept of trust can't be emphasized enough. There's a lot of activity going on in the IoT to think about collecting data, analyzing it, making good and better decisions based on it. But if that data isn't trustworthy in the first place, that's all just a fun exercise that really isn't going to get you anywhere. And even worse, it can get you to a place you don't want to be by guiding you with bad data to bad decisions. So I think the importance of trust can't be underscored enough. There are a lot of solutions that we've seen work in the enterprise environment that with some adaptation to the intricacies and differences of IoT, the different characteristics of the devices that are out there, the different ways data are going to flow. But there's a lot of good basic concepts that can be applied. Cryptography, which is an area where my company is quite a bit involved, provides a lot of those good bases. You know, a good trusted identity that can be authenticated in a way that traces back to somebody who you can decide whether to trust or not. The use of encryption to protect certain types of data, sensitive data. Now in the IoT, there's going to be a very wide range. There are environments where trust will not be as critical, and there are environments where trust will be super critical. And the application of that technology needs to match the level of risk. And there needs to be capabilities that are adaptable to these new environments in the IoT that can let you bring that same level of security that you have in the enterprise into the IoT environment, which is so different from a process perspective. So I see cryptography, signature, encryption, and the whole models that we've seen play out in enterprises around public key infrastructures with certificates that represent identities of people and devices have a very strong play in the IoT.
Okay, thank you. So at this point, I wanted to open it up to you folks. I have other questions. We can keep talking for a while here, but would you folks like to weigh in? Are there questions about cybersecurity technology in the IoT, in the industrial IoT, that you would like this panel to address? Here's your chance.
Can I ask a question of them?
Pardon? You can ask a question of them. Go for it.
So, hopefully you've done this, but how many people in the room use more than 2 or 3 different security solutions in your application or your product set? How many people use more than 2 or 3?
If I may, to repeat the question with the mic on.
Sorry, I know.
Once more?
That was.
How
many people in the room use more than 2 or 3 different security solutions within your solution or your set? Right? So, is that hard? Is it hard to figure out? Is it hard to decide? I think it goes back to what you were saying before, which is there's a lot of different great solutions out there, and you may have to use 2 or 3 or 5 to get things done all the way through, from the silicon and the end all the way through the firewall and the gateways and things that are going on. And it's amazing that, it's a hard thing, and we got to educate all these people too, because there's right. It's going to shows like this, but the education of cybersecurity and the models are really important, in my opinion.
You're right. Cybersecurity, not just the box of product you can buy from the shelf. It's also methodology. It's also consultancy. And
that's right.
If you have complex system, which is IoT in most cases, this solution can't be simple. It could be simple by technologies, but as a complex, it can't be simple. It should be definitely some deployment, lifecycle management, PKI, encryption. That's an important. Central management of all of this stuff. Protection of cloud infrastructure, protection of channels, protection of everything. So, I don't know really one company that could provide everything. All of us, we specialized on something. You specialize on encryption. We don't do encryption at all. It's not our key competence. We definitely should partner in order to provide the complex solution. That's it. We can't. Probably Microsoft, no?
If I may, if there's not questions from the floor, we didn't give him a chance. We didn't give him a chance. Are there questions?
Anybody have any questions?
There we go. Please.
Let's go for that.
There is a mic behind you.
Mic right there.
Okay.
All right, bear with me because I don't buy them many cybersecurity solutions. Our entire world, from silicon to boards, to chips, to boards, to embedded systems, to boxes of computers, to cloud, is based on layer upon layer upon layer of legacy infrastructure that is totally insecure. Now you can apply 10 billion security technologies in the entire infrastructure. Will you still have a secure world after all? What really needs to happen through that whole stack from the silicon all the way down to the cloud in order to develop a secure world starting from a legacy infrastructures by vastly is unsecure today?
That's a great question.
So, you know, where I would start with that is, that's one of the reasons why I think the endpoint is so important, is you have to already assume, your threat model should start with the fact that your adversary is already inside your network. You know, firewalls and everything else are all wonderful, but they're already in there. And if you start with that mindset, the question is, how do you stay operational with the adversary in your network? Your endpoint needs to know what other endpoints it can talk to. They need to have the ability of checking integrity and authentication of the data of who they're talking to. They may or may not need encryption, but they can't rely on a network to have all the proper VPN tunnels set up, and you start to scale. You know, you think about going in and installing, you know, a temperature sensor across my company's buildings all the way around the world. So you start out, you know, I'm going to put in, you know, 100 sensors per building. I'm going to probably hire multiple maintenance people to install them. You're going to roll these things across 20, 30 countries in the world. What are you going to do? Hand out username and passwords on pieces of paper to install the, you know, and register them with the system? It just doesn't work. And so you can't, you can guarantee someone will install it wrong. Someone will turn off the VPN pipe when they're not supposed to. You know it's going to happen. So you can't depend on the infrastructure, the legacy infrastructure, to protect you. You have to build things with believing everyone's already inside your networks.
I think to build on your point too, Doug, that one of the trends we've seen over the last few years is the manufacturers of the devices themselves, particularly the ones that are more aware of this need for the device to have some sort of a root of trust, have been building something into the device at the time of manufacture. And they do it for dual benefit. It's to benefit themselves to do things like prevent counterfeiting, and they also do that to provide an assurance that a customer that buys the product is getting an authentic product, and somebody is vouching for the validity of the firmware load and the configuration of that device, at least when it goes into your hand as the customer. And I think as we see more responsible IoT device production, we'll see that model continue to play through so that the trust can start at the device level.
Yeah, absolutely, absolutely agree. But I think the most important thing, to put security into the agenda from the very beginning, from the blueprint. You know, it's much more cost a lot of money and time to add the security than the system is up and running on a brownfield. On a greenfield, it's much cheaper and saves a lot of time. Put the security on the agenda at the very beginning, before you even start thinking about functional. That's an important. You save a lot of time and money. You know, that's bad for us because we earn money on consultancy or on the product and so on and so forth. But you know, we are on the customer side. Put security into the agenda.
Would you like to weigh in?
The only thing I will say is that systems integration of all of this, integration of all the answers, yes, starting from day one is extremely important. And who is going to be responsible for that? Within the organizations, we have the OT-IT scenario, we have a lot of things going on. Who is going to be integrating all this? What's the easy part? Finding the products. What's the application? What problem are you solving in industrial IoT? The integration piece seems to be an extreme challenge for a lot of people, especially when you're saying, okay, you know, we might have open APIs and be able to do all those things, but how long does it take to do? You know, and is it very, very challenging to be able to put it all together? So I think that's a major issue that has to be addressed also.
If I may, it is a major issue. What I heard in the question was what people are calling the greenfield, brownfield problem. And you know, greenfield is we're going to buy everything brand new and it's all going to be secure. This is, of course, nonsense. Nothing is ever secure. Security is not a binary state. It's a continuum.
Yeah.
And the thing is that in a lot of industries, we're dealing with low volume suppliers into safety critical applications. A lot of the low volume suppliers into discrete manufacturing are producing a dozen machines a year and selling them throughout, an industry. These machines are still running Windows XP. Why is this? It's because it costs $250,000 to €500,000 to certify any change, even a security update.
Right.
If you're selling 12 machines a year, it's not going to happen. And so people talk about the greenfield problem, the brownfield problem. I believe there will always be a brownfield problem. It's a fiction. It's imagination to think we're ever going to have a greenfield. And this is why, I keep harping on some of the traditional security concepts like perimeter security. Every important industrial site has a physical perimeter. If it's too dangerous or too sensitive for the public to walk up to and whack on, well, then it's important. Every important site has a physical perimeter to protect the public from the site and protect the site from the public, and has a cyber perimeter to protect the sensitive stuff inside that, I'm sorry, is always going to include brownfield components. This is the nature of the beast.
Actually, Andrew, you touched a very important point here. You said that security, cybersecurity, it's not a project. That's a process, never-ending process. You can't say, okay, I'm secure everything, and now and forever it's going to be secure. No, it's impossible. You should treat cybersecurity as a process, continuous and never-ending. That's the key.
And I would say, too, just to add, one of the game changers from a security perspective, you mentioned the perimeter. With these new devices, these are no longer under the protection of the traditional data center or some of the more physical means that protect your core servers and your core operations. Now you've got devices that are out there subject to people trying to plug something into them or electromagnetic threats. The whole threat environment changes. So you have to, again, kind of take a holistic look at the environment and rethink what might have been assumptions for traditional security that no longer apply now that you've got an unprotected edge of devices.
Right.
So I love that question. Did someone else want to chime in? What do you regard as important issues as far as cybersecurity for technology? Can you give us a question from the floor here?
Oh, 1, 2, great, fantastic.
Or a comment. You can join
That
the
works
panel
too.
if you like.
Hello.
Hi.
My feeling is that current public infrastructure is not scalable well from servers to sinks. And I would like you to comment on this and describe your vision of evolving public infrastructure for sinks.
I'm sorry, for SIM?
That's your topic.
For sinks.
Yes, please.
I'd be happy to tackle that one.
Yeah.
So it's actually an area that's close to mine and my company's heart. So a lot of enterprises have deployed public key infrastructures for a number of years. I think those of us that are old enough and gray enough remember the 90s when it was going to be the year of the PKI every year. But in spite of the fact that never happened, PKI has perked along as really a core asset. More and more applications in the enterprise, whether they're cloud applications or whether VPN or email or SSL, whatever, they're tending to draw certificates from that same public key infrastructure, and it's become a very important piece. One of the things that we've looked at very closely, and we do a survey with Larry Poneman every year to look at the evolution of PKI and what are the ties into the IoT. And one of the things that came out of that study was that almost half of the people today that have deployed public key infrastructure, and this is 1,500 or so respondents around the globe, say they expect to leverage their existing PKI for some subset of their IoT devices within a couple of years. Now, will their enterprise PKIs be up to the scale that IoT will get to? Maybe not. But I think what we're seeing is that starting point is that enterprise PKI that you've invested in and that you're relying on for other things, and then eventually probably a migration to the cloud when you get up into the thousands and tens of thousands and hundreds of thousands of devices that might be generating just too much certificate volume for an enterprise PKI to handle.
I would just add to that from my perspective, part of what needs to happen is a lot of the silicon that's the basis of how you do a secure boot and what you're doing, how you're getting your sensor data. Again, I keep going to the word endpoint for some reason. It needs to start to come with an identity. It needs to start to come with a lot of these basic factors just to allow the scaling. You can use the PKI infrastructure to manage things, but at the end of the day, you really don't want to have people walking around plugging cables in to 1 billion devices trying to put a key into a device and keep track of it. It's just not scalable. So you need to start having these infrastructures built into the silicon because it is your hardware root of trust. That is where it starts.
Great lead into my question. This is Adrian from ARM. So we are building that root of trust, and we are definitely creating secure enclaves on the CPU architectures. And my company that I was a part of just got acquired from by ARM. It was called Simility, and we were doing embedded SIM. So they understood that SIM being a control point on any device that's connected to a cellular network is an absolute place where we can create more secure environments. So my question to the panel is, as far as edge computing is concerned, and you're seeing a lot of these smart gateway companies, and I think it's this whole new gateway revolution, to be honest with you, that's taking place because of fog computing and blockchain assets. And I think my question is, how are they going to play a role when you talk about a perimeter security, but this is, not on the perimeter, well, it is to the cloud in some cases, but what would you see being a major trend in the smart gateway marketplace right now?
And if I may add to the question, smart gateway marketplace is the question. The IIC security framework for the Industrial Internet Consortium describes a whole spectrum of security technologies for organizations at different levels of sensitivity to risk. And we've been talking about technology maybe, independent of the organization's risk tolerance. If you're answering the question about gateways, could you maybe talk about where they fit in that spectrum? Because there's going to be, disposable devices that are deployed through a watershed to measure rainfall, and if the public comes up and kicks them over, the consequences are minimal. There's going to be critical devices deployed in railway switching systems and chemical safety systems, and if they're compromised and malfunction, well, things blow up and people die. And so where in the spectrum does the gateway fit? What kind of gateway technologies are you seeing, and who would be using them versus not using them?
I can start. So I think it's pretty clear that when you talk about some of the scale that we're looking to get to in the IoT, that security services will have to have some sense of distribution, and at that gateway point is a natural point where you can look out after the security services in a more localized way. The value of the IoT is in looking at broad data sets and correlating things across, but you also have things like local decision making, reaction to conditions in plants that can be critical, security services that are provided locally around those and protect that data in that sense, but also can share maybe a subset, maybe all, depending on the situation, some of that data up to the cloud so it can be looked at across several plants' operations. So I think just like the data structure needs to be distributed, the security services need to be distributed as well, and the gateway type products have an important role to play in looking after security from the edge up to that gateway. I don't know.
Fully agree. Absolutely.
To me, the gateway, a lot of that is a lot of the IT mentality of how you apply security moving down closer to the edge. It is a clear point where you can put up a firewall and you can do things and look at what's beneath it. So in that respect, it makes total sense. But I think that the reality is, as processing power increases, as decisions increases, as machine increases, you're going to see a lot of that processing power move down, continue to move down to the edge for real-time decisions. And so the gateway just happens to be a nice, powerful place that you can put traditional IT protections on today, and that in the future, a lot of those elements might need to move down as the processing power moves down, and the definition of what a gateway is kind of, in my mind, very morphic. I mean, it could be doing processing and making real-time decisions. It could just be sanitizing data of what actually goes to the cloud, because you don't want anything to be controllable from outside the perimeter of the factory floor or something.
You brought up two great points. One is I love the embedded SIM concept for security. We currently have a client that is in the embedded SIM area and is now looking at mobile security as a driving point for why you would buy their embedded SIM. If you look at the commonality of the embedded SIM and where it goes in the whole process, you're absolutely right. I think it's a critical piece to get in. From your gateway question on the edge, if you look at the amount of activity in the large computing companies around the world and the new ones like an Everblade and some of the other, in those situations, they're coming fast and furious. And I met with a company up in Boston that is in the fault-tolerant computers business and is looking to bring that to the edge in the gateway scenario, because I think the only way we're going to physically get to the analysts saying billions, or whatever the number is, we're going to have to do it on an edge environment in order to get that amount of data through from the edge all the way back out. So a silicon, and then using it in through the gateway or through the edge device, I think is going to be critical for the growth of our industry in general.
So, Andrey, did you want to weigh in as well?
Yeah, you know, if you're talking on gateway, so as I see the role of gateway evolve since, beginning of this century, it used to be just a transmitter of data. Now it's also not collects and stores data, absorbs the data. So in this regards, the threats are different. Risks associated with the gateway are different. So we should think how to tackle these risks and how to protect the gateway in this regard. So it's not only data in motion, but data at rest. And we should protect it and keep data non-modified, non-tempered, no falsified, whatever.
Okay,
And Andrew, your company is doing things. Now you're looking at the edge for some of your products. How does what you do fit into the edge?
we are focused on the perimeter, as I said. We believe there is always a role for the perimeter for the most sensitive systems, and most sensitive is defined by the end user. We only have a couple of minutes left. What I wanted to do was maybe give each of the panelists one more chance, 1 minute, 45 seconds. You've been walking around the show for the last couple of days. You've been coming to the show year after year. You've been looking at sort of the state of the world. Can you comment on your take of what's the state of the world and where do we have to go? What's coming next? Andrey, you were the last time. You want to start?
Okay, so first of all, I'd like to thank the audience for putting security into our agenda. This is the second conference for me, and the last year was, to be honest, pretty boring. So I managed to collect just 20 leads for 3 days. Now I collected 20 leads for half a day. The amount of people who is concerning about security and asking, okay, guys, I know that IoT is insecure. Please help us to make it secure, is growing since last year. Thank you very much for that.
Doug, do you want to go next?
Sure. I guess there's a lot of talk about security, and that is great that it's part of the agenda. At the same point, I think when you end up talking to a lot of the actual customers that we're making product for, there's still a reluctance of, is there value? I'm happy to have security as long as it's free. And then you bring up the subject, like you did, about it's a continuum. You have to have a posture of your product that you can give it an update. If you're going to install something in an industrial control system, you better have a way to update it for the next 15 to 20 years, because if you don't, there's probably a 100% chance something's going to go wrong and you're going to need to update it. So that continuum requires a different mindset by the customer of how do I handle the life cycle and what are the costs of that life cycle. It's not about that I add 5 cents on the chip. It's more about, have I set myself up to need less people, less cost over the life cycle of the product, and can I maintain it easily and safely? Then what is the incremental cost today for what's actually pretty trivial compared to the cost of hiring humans and putting up firewalls and tracking bugs and all that other.
Okay, John?
I think my point mirrors Andrey's pretty closely. We are actually chatting about it before we got in, but I think a lot of the cooler things that are going on in the IoT, the visualization, the analytics, one of the trends that we've seen here at the show is a lot of the folks that provide that are coming to us and saying, our customers are now asking us about security, and they weren't doing that 2 years ago or 1 year ago. So I think, again, that reflects security coming onto the agenda. It also reflects that there isn't a lot of core security expertise in some of the newer stuff that's coming up in the IoT. So I think the blend of what's known from many years in the enterprise and how that adapts into the IoT is the wave that we're going to see in the next few years. The realization is beginning to arrive.
And I get the last word. It's awesome besides you. Security still continues to be the #1 challenge in our industry for growth. I don't care what Gardner said, everybody is saying it. So to address it, you have to educate yourself. The show floor has everybody's booth and the amazing amount of different technologies. Go to those booths, talk to the people in the booths, and learn. There's so many different ways of being able to accomplish it. It is still hard, and so if you don't understand it, you have to educate yourself. But it is the #1 issue. It will be for the foreseeable future within our industry, because a lot of things are easy that you can do, but it is the most difficult part is understanding how to integrate it all and the education piece from my view.
Very good. So let me leave you with my parting thought. I agree with you, Steve. We talk to a lot of customers, end users, we're a vendor, and a lot of them will tell us, don't waste your time talking about cloud connections or IIoT because we have a strict policy from our industrial control networks. No cloud connections, ever. And so the security issue is huge. We need urgently to address this issue. It is impeding adoption of the IIoT in certain industries. Other industries where the physical consequences of compromise are acceptable, where all we're dealing with is data and privacy issues, that seems to be more under control. The high end of the spectrum where we're talking physical consequences, unacceptable consequences, they will not adopt this technology until we can convince the industries that we have this security thing solved. So I would thank you all for attending. I thank you very much, Steve, Doug, Andrey, John, for joining us. Please give them a round of applause.
Thank you. Thank you.